Morning, everyone. Really grateful for everybody to get up early this morning for this session. So we're excited to share a story about how Paramount partnered with Google Cloud Consulting to create a couple of really fascinating use cases. These use cases are designed to enhance the user experience for Paramount Plus. At the heart of our partnership and collaboration is a shared core value, putting the customer first. At Paramount, the AI/ML team begins by focusing on the user experience first and then works backwards towards how are we going to solve for that technically. I have a really talented group with me up here on stage, and we look forward to sharing how this collaboration works and discussing the use cases that can be applied to many companies in the media and entertainment space. My name is James McCabe. I'm a consulting account lead for media and entertainment at Google Cloud.
Yeah, hi everyone. My name is Sofyan Saputra, and I'm a technical account manager for media entertainment at Google Cloud.
Hi everyone, and thank you for having us. My name is Tereza, and I'm a lead product manager at Paramount.
Hi everyone, my name is Adam Leary, the VP of ML Engineering and Personalization at Paramount Streaming.
So we wanted to break this session off into a couple of different parts. So we're going to discuss how the Gen AI jumpstarts work and how Google Cloud Consulting approaches them, how we align to Paramount's overall business strategy, and then how do we approach this from an architecture and best practices standpoint. Sofyan, can you walk us through how the Gen AI jumpstarts work, how they're applied, and how we work with Paramount on those?
Yeah, absolutely. Thanks, James. So before going directly into the jumpstart, I first want to highlight how Google Cloud Consulting works with you throughout your entire Gen AI journey. We started by aligning on Paramount's Gen AI objectives. This included briefing meetings to overview our solutions, discussing on our cadence calls, and great brainstorming sessions with our professional services team to learn about all the possible projects that Paramount Plus might want to do with Gen AI. Afterwards, we provided training options like on-demand courses like hackathon jams, virtual lunch and learns, to help Paramount learn about the various Gen AI capabilities and bringing solutions through production. Through these efforts, Paramount got a lot of knowledge on Gen AI, and we came up with many potential use cases. We started by pinpointing 2 use cases to immediately work on. One is video summarization, and the other is video metadata extraction. This is where the jumpstart comes in. Before we get to fully implementing to production, we use the jumpstart to develop an MVP solution that demonstrates the capabilities of Google Gen AI and how the solution fits in. The jumpstart solutions are 2-week prototypes that help with quickly building a Gen AI solution for the target use case. We have 4 categories that include create, summarize, discover, and automate. Some example jumpstarts in the media space are creating a personalized marketing material automatically, doing Q&A against the contents of a video, and automatically tagging media assets. The specific focus are the summarize jumpstarts, which we use to accomplish video summarization and metadata extraction from Paramount Plus video sources. These jumpstarts help improve the personalization pipeline at Paramount Plus by getting finer details about Paramount's video library. So now you might be asking how we executed the jumpstart engagement. Well, the engagement is very well structured so that we can get the MVP as soon as possible into the customer's hands. To make sure the project is successful, we began by ensuring that the data is available in a digestible format. In our case, we collaborated to identify 10 sample video assets that would be a good representation of Paramount Plus films. This included videos with different durations, genres, and release dates. Afterwards, we collaboratively decided what the LLM outputs should look like before writing the prompts. Of course, as the engagement went on to execution, we iterated on the output and decided on additional metadata fields that would be helpful. During the engagement, we worked very closely to develop a Colab notebook that loaded the video assets and prompted the Google LLM utilizing techniques like few-shot prompting to provide specific examples and function calling to connect to external solutions like IMDb. This ultimately allowed us to summarize and extract metadata from the videos that could be used in Paramount's personalization solutions. As a best practice, we made sure to work in an agile manner, quickly iterating through feedback. By the end of the engagement, we had the prototype ready alongside a technical design document with details on best practices for implementing in production.
Thank you, Sofyan. So we have these two Gen AI use cases. Tereza, can you talk a little bit about how those apply to the overall Paramount strategy?
Absolutely. Thank you, James. At Paramount, our goals are ambitious and clear. Expand our subscriber base, retain viewers, boost engagement, and drive profitability. In media and entertainment landscape, AI isn't just an added feature. It is the critical component at the center of our strategy, essential for reaching our objectives. Through partnership with Google Cloud, we are leveraging AI to power a significant digital transformation. It enables us to create a highly secure, data-driven streaming service that not only understands users' preferences, but anticipates them. This AI-driven insight allows us to deliver highly personalized content recommendations, keeping subscribers engaged and reducing churn. So let's put this together with a straightforward example. Imagine a viewer who has just finished watching a sci-fi movie like Star Trek. AI enables us to suggest not just similar genres, but perhaps a documentary about space exploration or a series featuring strong female leads, tapping into that viewer's specific preferences. This tailored approach is built on our two core engineering objectives: a video summarization tool and metadata enrichment. Both are key in making content discoverable and relevant, creating a seamless and compelling user experience.
Okay, that makes sense. How about the product and engineering goals?
Well, our journey starts with the fundamental question: why are we doing this? The answer lies in our commitment to user-first perspective. It's about creating products that aren't just about innovation for the sake of technology, but are meaningful enhancements to viewers' experience. In product and engineering, we're actualizing this concept by building systems that do more than just house content. They actively serve it up in engaging ways, keeping our viewers engaged. Imagine this: a user browsing our platform finds a collection specifically curated for them, narrated like a story with a beginning, middle, and end, aligning with their interests. This video DJ approach isn't just smart, it's intimate. It understands if the viewers like Christmas tales, Halloween frights, or the allure of Westerns, even if the original content did not come with this metadata. Through rich, nuanced metadata, we can sift through our classics and hidden gems, creating personalized collections. This isn't just curation. It's about creating a connective thread with our viewers and guiding them through their journey from one video to the next. This strategy is our digital evolution in action. With each AI-informed decision, we're reinforcing our strategic pillars, sparking growth, and most importantly, strengthening the ties we have with our audience. Let's look at the compelling reasons for automating summaries and metadata. Currently, over 50,000 videos require summaries and metadata tagging. It all translates into thousands of hours of manual labor. Automating these tasks can recover substantial time for creative and strategic pursuits. Additionally, metadata procurement from third parties is costly and often yields results that lack the detail we require. This isn't just about cutting costs. It's about gaining control over nuances of our content. Remember, metadata isn't one-dimensional. It plays a dual role, powering our machine learning algorithms to fuel our recommendation system and providing viewers with the content they need. Good metadata improves content discoverability and personalization, yielding a better user experience. By refining our approach to metadata, we're not just saving on third-party costs. We're investing in the intelligence of our platform and the satisfaction of our audience.
Thank you, Tereza. That really puts it in context. It's really easily to understand why and how it fits in. So Adam, when you're approaching these kind of AI projects and use cases, how do you think about putting them into production and maybe share some best practices around that?
Sure, great question, James. And the answer is really multifaceted, so let's dive into that a little bit. So first of all, in the overall workflow, we want to think about how to start simple and see what we have with what we get with what we have. So we also want to establish some gold standards around the generated output itself. So what are we really after here in the output? So for example, is the goal a generalized plot summary or a summary with a voice or a point of view? So those standards will keep you on target towards the goal of the outputs that you might have. So we also want to establish the source video locations. So for the purposes of the Jumpstart, we decided upon using our videos in our public YouTube channel to allow us to focus more on the generation phase. And then finally, the prompt engineering was a big part of the process itself in the Jumpstart, and that also helped us to get to our goals and to talk now about some of the best practices. So one of the most important aspects here is really the outcomes of the LLM that you may be using. So the response isn't really as effective if you don't have a well-detailed and clear prompt with some constraints as well. So the Jumpstart process really helped us with addressing some unforeseen challenges. So for example, transcripts in some cases, like for movies, can be quite long. So depending on the LLM you're using, the token limit can really play a big role here. So one of the techniques is to chunk that out and then aggregate it back at the end. And also, since we're dealing with movies and shows with mature themes, we needed to address the safety filters and to allow us to have the outcomes that we needed and address the safety filter settings itself. So the overall philosophy here, once again, can really depend on the LLM that you're using. And to some extent, that is very important. So for example, for Gemini, it's really good at a few things in our experience. So one is the prompt chaining. So this is the process where you're taking a task and breaking it down into subtasks. So it's a really good idea to do this so that you can control and constrain the context window itself. It's also a really important technique for helping you to debug your processes as they are running in production. And it'll also reduce the workload that you might have downstream, especially if you're using something like LangChain. Also, as we mentioned earlier, token limits can be a really important factor here, not in the sense that how you use them, but also in the trade-offs that you have to make. So for cost optimizations, it's really important to consider the model size, how much compute it takes, and the accuracy trade-offs as well. So in some of our initial work, we also did prompt generation via the LLM itself. So have the LLM generate the prompts that we might want to use, and then we iterated from there. And lastly, of course, you want to determine the temperature and top P and top K settings that you need for the goal that you have. So to recap here, we've talked a little bit about a general workflow and some of the best practices that we established during the Jumpstart.
Can you drill a little deeper on the architecture and how that is put together?
Sure. So here we have a reference architecture. And it's important to call out that some of the choices that you will make really depend on how your services interact with other services within your overall system. But here what we're looking at are three components. So one is the transcription creation, the second is the generation phase, and the third is the personalization component. So the first row, the transcription creation, is really the process of taking the source video in a bucket and doing a muxing process, and then running it through your speech-to-text system, and then outputting that back. So muxing stage here is really where we're dealing with the audio process. So for us, most of our videos are in HLS, that is HTTP live streaming format. And so we're going to try to select the highest audio quality possible so that we get the highest quality output of the summary. The SST, the speech-to-text process itself, is a fallback method if we don't detect that we have a transcript or the transcript that we do have is not of the quality that we need. And here also it's important to call out that you have a choice in how you approach the model here. So of course you can use a Google managed service model or you can use an open source model. And in our case, we're running a Whisper Distill version 3 and containerize that, and it runs as its own service. So now let's move on to our second row. So the second row here, once again, is the generation phase. So what we're doing here is we've created an event trigger once that transcript lands in the bucket, and then we're running our generation process, storing that off in something like a Firestore key value, so the key being, for example, the content ID. And then that's available for updates within the personalization system. So the updates here might be other back-end processes that are outside the purvey of our system. So that might be content management or media asset management systems. And I also want to point out it was in this phase during the jumpstart that we really worked a lot on the system prompts and the input prompts as well. And then later on, what we've done is we've templatized these prompts so that we have full control over how they run. And then the third row here, the personalization component. So here's the phase where we're joining back to our clickstream data, so the user interactions on the application, and then adding in our enhancements, and then making them available for feature updates. So one of the key reasons for the summarization project itself, other than the display use case, is it's also informing personalization features. So we want a concise overview of that asset of what a customer sees on the application itself, because it's a really important component of the overall visual gestalt of how one selects a movie or a show. So it's also really important to point out that's not represented here is that we're also creating embeddings off of the transcripts themselves. And then we have an endpoint that makes the output available in a JSON. So another point to consider here is the overall size of the embedding space. So I mentioned we're creating embeddings off the transcript. So the standard that you set here is really important for your downstream processes. So in this case, we approached it with some LoRa fine-tuning to basically shrink down the embedding space to the size that we needed. So why? Well, we want to create the most information-dense space possible, and it also allows us to start to explore to run smaller models on one GPU. So further, in cases like transcripts, you could go with something like a Gemma 2B instruct and use a grammar to show the system what a transcript should look like. So in essence, our approach is to move towards an agent-like approach where we have different agents running for each component of the system. So to recap here, we've talked a little bit about a reference architecture, but let's step back a little bit and look a little more at the fine-tuning process.
Awesome.
So the continual feedback is a really important prospect of any adaptive system like a personalization system. So for example, on Google Cloud, the reinforcement learning fine-tuning process is supported by several model types, like a T5 or say a Gemma. So the flow right now on Google Cloud essentially works like this. So first of all, we have a human preference data set. So for in the case of summaries, it might be a random selection of summaries of different movies where people have determined that they are accurate for them in describing the film, and also eliciting interest from them as well. So this might be sort of considered a portion of the discovery process as a whole. And then ideally, you want to set up an evaluation data set that's unlabeled. So once you've tuned, you can run against your evaluation set. So the human preference data set itself is then used to train the reward model. And then you update the model weights, store those model weights off, and now that fine-tuned model is available. So this process can be continuous. You can run it on some sort of update schedule that you need as well. So once that is complete, now we can start to possibly looking at using different types of models to examine the evaluation phase to really hone in on the process that we're after.
Thank you. So we covered a lot of content in a short period of time. So I think to cap it off, let's just talk about some lessons learned and the impact and some practical advice that the audience can take away from this. So Tereza, what are some of the challenges that we faced when we were going through this?
Reflecting on our journey, we encountered a series of challenges that tested our resolve and ingenuity. The first significant hurdle was aligning our vision with practical realities of AI implementations. It took us 4 different iterations to refine our MVP prompt to meet Paramount's expectations fully. This iterative process was crucial in shaping our tool that it wasn't just technically proficient, but also strategically aligned with our content objectives. Another challenge was the variety in our content. We needed our AI to be able to be agile enough to handle various videos of different types and genres. This wasn't a simple one-size-fits-all solution. It required a deep understanding of nuances of our content and the flexibility to adapt our AI. Experimenting with such a range meant that our AI had to be fully versatile and sensitive to context, a challenge that pushed us to innovate continuously.
Yes. So Adam, can you talk a little bit about the results and the impact from your perspective?
Sure. So from our perspective, the technical design documents that were one of the outcomes of Jumpstart were really important and highly practical for us. So let's talk about some of those outcomes from each of our projects. So the first project being the video summarization project. So one was around model validation itself. So it really confirmed a hypothesis that we had, which was the inclusion of a really clear context with specific examples, and then accompanying the transcript really added value to the output itself. So this is back where I alluded to before also with the prompt chaining. We had a lot of improvements discussions, meaning what will we do once the jump start's over? So what were some of the areas that we discussed? One would be an area called the chain prompt templates. So you might want to classify your prompts by different types. So for example, genres or microgenres. And once you have the summary, associate those with different audience affinities themselves. So the second is what would be called the candidate selection strategy for selecting summaries. So here you might want to imagine something like an encoder-only classifier and say use it to inject an estimated score for the summary, which you can then use in A/B testing. And then finally, we talked a little bit earlier about some of the fine-tuning that you can consider, because typically fine-tuning will outperform pure prompt engineering. So that was something that we wanted to make sure was on our roadmap as well. So given this was already in our plans, it was a nice validation.
Yeah.
And then moving on to the other project, the metadata generation project, we had some discussions around dynamic metadata key values. So what do I mean by that? So the dynamic piece really has an important impact on personalization for several reasons. So one is accessibility. We can promote useful metadata for our customers based on their affinities and needs. So it doesn't necessarily have to be one size fits all. So that leads us to the next point, which really moves us away from the concept that there's one description that moves across the entire application. And that begins also to reflect our audience's interests and needs as well. And then finally, something that Tereza has touched on is we're very concerned with the overall experience of the application. And to us, the metadata itself is a really important set of latent features for potential interest when we're talking about discovery of content.
Yeah, thank you. So Sofyan, can you give us some lessons learned that we had from a Google Cloud consulting perspective?
Yeah, absolutely. So there were 3 best practices that we learned through this project that I want to highlight. So the first is getting access to the videos and expected metadata output before the engagement began really helped us hit the ground running and provide a North Star for the solution. Second, experimenting using videos of different length, content type, and time periods really helped us address difficult scenarios such as long transcripts, films with mature themes, and when to integrate function calling to structure information from outside sources like IMDb. And third, gathering feedback early and often throughout the engagement is valuable for getting the desired end result. We got this feedback through daily communication and in-depth working session. So these are the 3 key lessons that I really wanted to highlight and we can apply to future projects.
Yeah, absolutely.